My name is Saul Montoy, and this time we are going to do a tutorial to estimate rainfall for a given return period with Python. In this time we are using Jupyter Notebook, that is interface for Python, and what we are going to do is to deal with data that goes for a precipitation station on a daily basis from the 63 to the 2010, I guess, to 2010. So we have around 50 years of precipitation, and we are going to deal with this with Python and NumPy and Pandas. So first we call in this part we call the libraries Pandas, NumPy, and Scipy to do the spatial statistic distributions. And this command is to get the graphics after the cells. And then with this command we open this file. This file is this one, and we open and plus we say that this column is the index, but in fact is an index of dates. So it actually recognizes that these ones are dates and treat it like dates. So and this is very powerful, and with just one sentence, with just one line, you can deal with 50 years of precipitation. So we run this, okay, and then it is already on the memory, and then we can plot to see how our precipitation records are. So here we have our precipitation. I don't know why, but if I run it again, okay. So here you have the precipitation records that we have mostly continuous. Maybe in 2005 we deal with some missing data and some less. We have on 95 a very high period that was not recorded anywhere anytime else. So very interesting to know what had happened with this one. Okay, so with this code we are going to do an histograms with bins, that is the number of columns, 30 columns, and these ones are just options to make some styles. So in fact do not make any operation at all. And here we have the histogram. This is the histogram for the whole precipitation data, but in fact, and this is something that I didn't find on my hydrological groups, is are the precipitation estimation or for a given return period done with the whole set of data or just with the days where there was precipitation. Because why? Because if you see this distribution is not capable, as you will see on the notebook, is not capable to be resolved by any known any known distribution on Scipy library, because we have a lot of data that have no precipitation. So what we do is we get just the days. So we get Yauyos is our data frame, and we get just the days where there is precipitation, so that is more than 0. And we create the histogram, and this is the histograms of the days with precipitation. And now it seems it doesn't fit so well with a precipitation distribution, but it fits better than to deal with this one. Okay, so in order to compare, this is the histogram. So what does it mean? That this is the number of times that this interval has been recorded, and we are going to normalize it. Why to normalize it? Because in order to compare with the precipitation, with the probabilistic functions, we have to use it and normalize it where all the area that is below this, or this that is on the columns are the sum is equal to 1. Okay, then in order to estimate the rainfall for a return period, we are going first to fit and to see how our precipitation is more related to a probabilistic distribution. So in order to do that, we need to get the average and the standard deviation. So the average is 5.58 and the standard deviation is 4.96. Okay, so and then we with these commands, first we do an array, yep, and then we get the PDF, that is probabilistic distributed function for the normal distribution for the Pearson tree. Pearson type tree is the log normal distribution for Weibull and for chi-square. So with this one we get the array that will represent which is the probabilistic distribution for this average and from this standard deviation. So if we plot this, by doing this, what we are doing, we are plotting again our histogram, plus we plot a line with some styles of the normal distribution, the log normal distribution, the Weibull distribution, and chi-square distribution. And these are functions just for the size and where the legend is done. Okay, so I'm sorry I didn't run this one, so I run it and then I run it again. Well, I run it once again because sometimes this last command do not run on the beginning. Okay, so this isn't that beautiful? It is, I guess. So what does it mean? It says on this gray line you can see the normal distribution, and then the main question is, our data fits the normal distribution, yes or no? No. Why? Because the mean value of our data, the median, is here, where the normal distribution give a median here, and plus the shape is not the same. The second one is the log normal distribution. The log normal distribution is skewed. According to the USGS, the Geological Service, on water resources it's better to use the log normal distribution for the fact that water resources data is never negative. So you cannot have negative precipitation, you cannot have negative no negative precipitation, no negative concentration, and so on. So, and if you can see this one, this dash blue line is the log normal distribution, and it has a better fit. But if you compare to the Weibull distribution and to chi-square distribution, by sure has the best fit of all of them. Okay, and what we deal is with a concentration. What we deal is with a distribution that actually is a good approach to the probabilistic distribution of our values, but it's not perfect. And if you can see, our values goes from 0 to 30, and here we run the probabilistic distribution for them. Here we, for a return period of 100 years, we get the rainfall, the daily rainfall event. 100 years means that the probability of excellence is 1 divided by 100. So the cumulated, or like the interval of confidence, is 1 less 1 divided by 100, that is 0.99. Okay, so here we have the commands that do the normal distribution. So that actually for the for this accumulated precipitation, or like the interval of confidence, give the event. So this is this comes from Scipy. Yep, and it does it for normal distribution, for the log normal distribution, for the Webull and chi-square, and these commands are the ones that print them. So if you see, we have different value if we select different uh, if we select different distributions, we have different values. Chi-square is giving us the highest value, while normal distribution give us the lower. Our best approach is to use this log normal distribution, okay, and is supported by some recommendations on the literature. And here is for 200 years, so 200 years, the return period, the probability of excellence is 1 divided by 200 years, and the interval of confidence is 1 minus 1 divided by 200 years, so it's 0.995. So, and here we have, so the precipitation for a given period of 100 years is 20, the precipitation for 200 years is 22, and the precipitation for 500 years is 25. So these are the estimations. Okay, I have to tell you something. Have you seen this event? Something happened on these years that was never recorded before. We don't know what happened here, but it's really skewing, and maybe it's not giving us a good value, because we have for 500 years a return event of precipitation, of daily precipitation of 25, while we have recorded the data of 30. So in this case, on the programming part, this exercise, I mean, you can apply this for your data and so, but on the data quality part, something is going on with this data. So why here we have like 3 years of higher precipitation that were never recorded in any other. So we have maybe to focus to go and to have a deep look on what happened on those years, maybe try to fix it, or maybe just is like it happened, like it was an extreme, not extreme event, but there were like 3 years of extreme events. So that will be all for this tutorial. I hope that you have liked it. Please follow us in facebook.com Hatariwater and twitter.com Hatariwater, and subscribe to this YouTube channel if you want to get more tutorials on Python, Modflow, and HKHMS and other software on water resources. Thank you.